السلام عليكم ورحمة الله وبركاته. ده كده بارت 2 من هيكل العاشر انسبير. لو انت ما سمعتش البارت الاولاني ارجع اسمعه الاول وكمل بقى علشان المسائل هتبقى تباعا كده بالترتيب بإذن الله. Let's continue. طيب. Here firstly we talking about the voltage, the current, and the amount which are increased by the amount. So here if we having a resistant, this resistant it was increased, this resistant it was decreased. So we having voltage, we having the current, we having the series which are parallel or changed. So here it was page how much was 90, so it was 96 as so he increased it, and you should focus at this net. Here page 69. So the difference between the pages and this box, it was 4 pages. Don't forget. So here it was page 79. Here it was 89 as that. So we will increase 4 pages. Okay. The difference if you have an old version of this box. So the difference 4 pages only. Don't use more than one book. Only one book. And if you have this video, you should continue to find the solve, inshallah. Type. This was question number 1. We had finished from 13 to 18 at the previous video. Now we going to the second question. Analyze the simple electrical circuit that contain combination of resistor battery and elevate a current passing each resistor and a potential difference across page cam 91. So we'll go back to you should continue. It was 4 pages, so it will be 950 95 95 95. Yeah, this page he needed to draw that we have talking about before. So we have shapes, okay? That first one. So maybe we had mentioned this before, that the difference between the circuit. So we have conductor, we have resistor, switch, and potentiometer, fuse, here a fuse, and the ground, battery, DC, lamp, ammeter, voltmeter. So we have a difference types here, capacitor, inductor. So all of them used it for if you needed to draw. We had mentioned this draw before, if you remember, at the previous video. So he needed us from question 8 to question 12, 92. So we had finished this before. So your first video, it was containing question number 1 and question number 2. Okay. If you needed any repeat, tell me in comments, inshallah. Number 3. State Ohm law and identify device which obey Ohm law and apply it if it to simple circuit delta V equal I R. Why he changed R I? It was I R. Was not important. So it was page again. Why he repeated? Page he needed only get it in question 21. Okay. He need again state identify. Okay. Let's go to this page and seeing what he needed. Again, it was page 34. So it will be 70. Okay. that page. Yes, we had mentioned this before, and we had mentioned that Ohm law and the difference between resistance and different between that value. So we had mentioned this before also, and we had mentioned the difference and I equal delta V. He may be needed to add question number 21 to be solved. 21 not here, 21 here. Resistant, just that because R equal delta V over I, if he increase the voltage and the resistance will increase. Joe, correct? Explain. So he needed us to talk about the value of that bit. Wait. Here we can talk about is here. So he needed us to talk about what? The relation in R and I and V. So V is a command. Why? Because if we increase, if we increase in current, the value of V will increase. Mm. So here also the resistant. If we increase resistant, the value of voltage also will also increase. Oops. So here, here, both of them are increased. This is the first why we said he is command. Because that one increase, he don't care. That one increase, he don't care. He always increase. Next one, R and I. He is inversely. Wait, why? Why I type it like that? R. It was inversely with I. So if we increase it R, the amount of I, it will decrease in that voltage if it was constant. So we making voltage constant. So increase R mean decrease I. Increase I mean decrease R. So both of them are inversely proportional. Okay. This one it was super important to understand and getting. Why? Because if we having inversely proportional, it will be shown at this point. Okay. So we knowing now we having and value which are inversely proportional. That's what he wanted us to describe. So here now, Joe, because this resistant, okay, if he increase voltage, mhm, the resistance will increase. Yes, it will, cause we are directly proportional between V and R, but inversely between I and R. So he don't mention R. I. He needed only R and V. So you should focus at the law, what he wanted you to know, or what did he wanted you to do. This is the question number 3, and the pages which he mentioned. He mentioned also 97, maybe 101. This also here was the pages He mentioned any question again. Get it and question 4. Okay. Let's go to the fourth question. Explore connecting resistor in series and parallel and determine the properties and use of each kind of connecting by studying the electric current and the potential different across each resistor. So he needed us to explore the connected series and parallel. I already explored it, but I will make it again. He mentioned us to do it. So using electrical energy, it was not in this. Maybe I see parallel here and series here power. He mentioned it was at that one. Maybe he needed something also. He needed page 91 and here 4. So it was at 108, 108, and that one. Yes, here series and parallel. So let's talk about it seriously together. Firstly, we talking about series and why it was not type. Oh, and parallel. What does that mean, parallel? Parallel, it was that amount which are connected like that, one and one. So it was here upward and downward. I cannot understand. Okay, let's get another explanation. Let's change this color to that. Let's talk. So we have an answer. When we having the current, here positive, okay? Here negative. The resistant continuously connected. Continuously, here positive, here negative, positive, negative, positive, negative. So it was continuously. So this called series. Why it was series? Because it was connected here. One going to another, going to the third. So it was continuously positive, showing to the negative, positive, showing to the negative, and it was continuous. But we're talking about also one thing. It was parallel. What is the parallel? It was that amount. Look to the current. Oh, what happened? Like that it was divided. Divided into what? Like when you're going in the road and you find two cross where you should go. That's the current making the same. When he going to that one, that wire, he find two ways to pass. He confused to where he can go. So that means the current he confused it now. Some can going there, some can going to another. That meaning the current will divided. The current it was different in what in connected in parallel. Why? Because he confused. He cannot going in one way. He going in two ways. That means the current it was here R1 not same as R2. If we backing to that one which we are talking about series here, no, here we going the current it was always here I1, it was I1, it was I1, the current not change it at all. Why? Because he didn't divide it. There, we divided the current. Now, we don't divide it. So, in connected at series and connected at parallel, we can sing one good thing. Connected in series, it saved the current I, it was constant. Here, it was not constant. What is this current? Was not constant. Also, here in series, voltage was saved, but it was divided here V1, V2, V3. Why? It was changed in that one. But here in parallel, it was not changed. So V1, it was here V equals that V, not a change. And connected in what? In parallel. So we have two ways parallel series. Here in parallel, we said that amount going to here current, it was constant. Here's the voltage who are constant, V constant. I no was not. Mm, Also, we having another thing which are talking about the connected here. Yes, if it was say, three here, it was three here. So the total resistance we said are equivalent. Are equivalent. Maybe I should making the book bigger so the amount of reading it was bigger. So it was here three plus R equivalent. If it was connected series, it was plus how much plus? It was 3 plus 3, 5 4 plus 5, 6 plus 6, 8 plus 8. So it was added. When we added the current or the resistance, because it was here connected in series. 85 plus 85, any number, it was added to find what? To find the resistor. Hmm. But it was different where in connected in parallel. What? In connected in parallel? But let's calculate this question. He mentioned it, I thought. Question number 24 till 46. All of this, he mentioned them. So let's calculate firstly. Three resistant, three resistor, and connected series. So you should make like that. 3 multiplied 22. It was 66 ohm. And here's the voltage V. It was equal 125 volt. So this V. What is the equivalent resistor? Equivalent. So we should making it like that. R equivalent equal R1 plus R2 plus R3, 22 plus 22 plus 22, like that. So you should type mini. So it will be 66 what? Ohm. Ohm. Okay. We had find this one and we had type. Okay. What should we do also? We find the current. I equal V over R equivalent. So it was V 125 over 66. 125 over 66. It was 1.89. That was the current ampere. Thanks. The second one, we having an O. It was 12 O as R. Uh, we have also 15 and 5. All of them connected series are equivalent. Equal R1 plus R2 plus R3. We should type the law. 5 plus 12 plus 15. It was 20, 20, 32. All are equivalent equal 32. Okay. Here it was voltage V equal 75. What should we do? What is the R equivalent? We had calculated it before. I equal V over R. I equal the current, voltage over resistance. Voltage is 75 over 32. How much it will be? It will be, let's go about 2. Yes, 2 and 75 over 32. It was 2.34 ampere. We don't forget this one, ampere. Also, we have an question 44. A string of a light has 10 identical bulbs with equal resistance connected series. Okay, string have a 10. Okay. And the light connected, he had a V. It was 117 volt outlet. The current through the bulb كذا I equal 0.06 ampere. What is the resistance of each bulb? Oh, he needed to calculate all R's, but we have R equivalent first. R equivalent, it was from what? Let's change this color, making me dizzy. Maybe this is good. Let's try. It was R equivalent. So the amount we so it was R equal how much? V over I. V 117 over 0.06. So the resistance was bigger. Y 117 over 0.06. You make mention it. Yes. So it was 119.50. 1950. It was R. Okay. Another thing, he needed all the resistance. Okay, what should I do? What the same number we said R equivalent equal N R. I needed R only. R equivalent over N. How much N? It was 10. How much R equivalent? It was 109.70. Yeah, 50. Over 10. 195 ohm. That one, which are only the R equivalent. So here also another thing, a strange alley of light that has 10 identical bulbs with equal resistance connected in series. When the string of light is connected ماشي قلنا لسه خلصنا ماشي هنا number voltage V equal 9 volt. Battery is in circuit with 3 resistors. Oh, we have R, it was 3. Okay. Connected series, جميل. If the resistance of one of the resistors increase, how will equivalent resistance change? It will increase because it was series. So R equivalent equal R1 plus R2 plus R3. If we increase one, all all equal are equivalent. يعني أنا زودت هنا دي هتحصل لها increasing، زودت هنا ده هيحصل لها increasing برضه. هنا increase برضه because all of this added. Um, what will happen to the current? Current, it will decrease. Why? Because it inversely proportion. Okay. Another one, will there be any change in the battery voltage? Let's see. We have a battery and the change in voltage. No, it will not change. No change. Because the battery it was the same. 46. Calculate potential difference. He need V across 12, 15, 5. It was just the same here. See, same here, 34. That are connected series with 75. Verify the sum potential difference equal across the battery. The sum of these potential difference. تعال نشوف هنا وهنا وهنا. تعال نشوف. بص. question ده اتغير عن question 34 a little bit. ازاي؟ total resistance it was 32. Okay. Let's calculate the R first. And we will calculate it for 12 ohm, the potential difference. 5 ohm, the potential difference. 12, okay. 15 ohm, the potential difference. Okay. We have a total resistance R equivalent. We should calculate it I firstly. It was V over I. R. It was 75 over 75 على 32. This is the first one. This is I. Okay. So you should type I equal V over R. How much is the V? It was 75. And the amount, it was 32. So the amount of the current, it was 175 over 32. It was 2.34. Okay. Let's calculate. We calculated what? The potential difference in the first one. We type like that. What should we type? We should type V for 12, R12. Okay. It was IR. It was 2.34 multiplied at 12. The next one, V equal 4, 5. IR 5 multiplied 2.34. V 15. It was equal 15 multiplied 2.34. And we added all. We find the same amount of the voltage. That mean the current. That mean all the amount, it was the same. If we don't have internal resistor, we will not change it at the total voltage or potential difference. وده كان الفيرستلي. What he talking about that series. Did he mention any parallel connected? Yes, he said parallel. Using the kind of connection, studying the electrical and potential difference. Let's go to the parallel to continue this question. All what he said, all of them. Here's the potentiometer. Here a question talking about the parallel, the series. It was here an amount V. It was I1, I2, V1, V2, V equal IR for anyone. Here let's calculate if we need. So we have a V was 45. Here we have a resistor number one. It was 74. And the other one, it was how much? It was here 82. So we have two resistant. We should add to get R equivalent. R equivalent equal 82 plus 47. It was 69 and 96. 96 ampere. So we should ohm. So we should get the current I equal V over R equivalent. V, it was 45 over 96. 45 over amps. Why? Over, not over. It was 0.23. Why he mentioned it? It was 35. Again. Maybe I make a mistake. It was not that value. It was make it like that. 45 over 47 plus 82. So 15 over. Oh, it was here 0.34. Yet it will be 35, 0.35 as he mentioned. You need to skip. So here we find IRV. It was that amount. So we should calculating V equal IR and the value it will be calculated. So we had calculated the amount of I. It was 0.35. Let's calculate here. This 47, this 82. We can calculating the V1, V2, I1, R1, I, R2, R1. How much? It was 45 multiplied 0.35. The next one was the same 0.35 multiplied 47. 0.35 multiplied 82. So we calculated the current for each one here. Add that value. So we can using the amount here delta V equal IR and the resistance here it was 16, it was 29, 97, 29 volt, and here we can calculating the amount of the total current if we have an delta V over the new resistance. He need to calculate it using new resistance. So the amount of new resistance, it will be how much? It was decreased it from 47 to 93, 39. That means the amount will increase or decrease. It was decreased the resistance but increased the current. It was increased from 0.35 to become 0.37 if he needed IR also. We not started yet at parallel. All of this talking about the series and how can we connect it at series. So we started now at parallel or resistant. How can we find? Let's talking about 1 over R equivalent. It was 1 over R1 plus 1 over R2. What is this semester? It was the way to calculating the amount of that are equivalent. We have two ways. One, it was easier than the other. Okay. We can type like that. R1 equivalent. Power -1. Why we put -1 if we cannot use the difference here? So if we have two parallel, here we have an parallel number one, it was 5. The other one, it was 5. So the amount here, it will be who are equivalent 1 over R equivalent 1 over R1 plus 1 over R2. It will be 1 over 5 plus 1 over 5 -1 or -1. It will be 2 over 5. It will be, we should calculate it like that, 1 over 5 plus similar 1 over 5 power -1. It will be 2.5. This is the right way to calculate. Sometimes people make like that 1 over 5 plus 1 over 5. It was 0.4. He can stop now. No. He make equal. Then again 1 over answer. So that it will have the same. But easier, we make it like that. You make 1 over 5 plus, or if it was 1 over 2, plus 1 over 2, say, power -1 was equal 1. So if it was 6 and it was 5, it was 2.7, it was 6 and it was 6, it was 3,